All right, seventh graders, back again. Here we go. We are going to start putting some of this chemistry stuff to work. Monday's video was chemistry basics, trying to learn a little bit about why we are going to be doing this as far as what it takes for the chemistry side of this. Tuesday's video, some of the balancing equations basics. I know for some people, not real clear. I get it. Sometimes I think that maybe doing the problems might help. So today's video is going to be about practicing a couple of these problems to make sure you guys are on the right track here, okay? All right, now where we left off on our last video, you guys were at a presentation where you were looking at an actual chemical reaction, a chemical equation that it was. So I'm going to share my screen again because we're going to be at that same exact spot once again. So here we go. Make my screen just a little bigger, make it easier for everybody to see. Okay, so guys, where we had left off on Tuesday was we were looking at this equation that you see right on your screen. And I've got it written up here on the board. Notice that mine looks slightly different than yours. That's because I put in spaces for us to add these big numbers, these coefficients that we talked about yesterday that can be distributed out to the elements in each of these groups. So that's what these are for. But guys, if we remember back to our equation, it's always made up of our reactants. Reactants are anything that are going to be to the left of this arrow. And remember, the arrow doesn't mean that it equals something. It is simply changing the way that it looks. So when I take magnesium, add it to oxygen, we get something called magnesium oxide. Okay, that's the whole problem that we're going to be solving. Now, in order to do that, we are going to have to use our RAP table because we have got to isolate the elements first. We got to figure out what our ingredients are in order to figure out what our products are going to be. And if you remember back to what we talked about yesterday, guys, the ingredients are always going to match the product. It just might not be the same number of them. The law of conservation of matter states we cannot create or destroy anything in a chemical reaction. We're not going to do that. We're going to just change the way that it looks. So the first thing we're going to do is we got to figure out what elements we're working with. So when we look at these reactants over here, we see that we only actually have two elements that we're working with. We have something called magnesium, which is a big M followed by a little g, and we have oxygen as well. Now here's the awesome thing, guys. As we work through this, whatever reactants we have, those things are going to be found over here as well. So I'm going to go ahead and notice that I left a little bit of space here, and that's because I'm going to be writing some numbers next to these, and I'm going to show you guys how we balance this out, okay? All right, the first thing we do, guys, is we look at each of these and we decide how many atoms of each element we have. Now, there's no big number in front of the magnesium, and there's no subscript after it. Remember, a subscript's that little number. Guys, that subscript is only attached to the element that it follows. So if I had a subscript over here, let's say it was like right here, that would only be attached to this oxygen, not to the magnesium. But we don't have that, so let's not get ahead of ourselves here, okay? So guys, when I look at my numbers here, because there's no big number and there's no subscript or little number, that tells me that I only have one atom of magnesium in the reactant side of this equation, okay? Simple enough, moving on. When we get over here to the oxygen, notice we're still on the left of the arrow. This is a reactant. Do we have any big numbers here? We don't. But we do have a little number here, and that little number is the number 2, which tells me that to make that element, that molecule, we have to have 2 oxygen atoms to do that. So that means that there are 2 oxygens over here. Now, guys, we have our numbers. We're now going to shift over to the product side and take a look at them. Big number, there is none here. That means I have no number distributed to any of these. There's no little subscript that comes after either of these elements. That tells us that there is 1 atom of each of those on the product side. Now you guys are probably going, wait. The law of conservation of matter says we can't create or destroy anything, but these numbers are different right here. These numbers are fine, but these numbers are different. That's what balancing chemical equations is all about. Here's how we're going to do this. And you guys can actually use that PowerPoint presentation that I attached on Monday because it kind of walks you through the same process. I'm doing it in real time. Here we go, guys. In order to make this balance out, I have got to add big numbers to certain sides of this particular equation. And then once I add that big number, I distribute it to make sure that all of my numbers over here are going to balance out. Key thing to take away. If the numbers are the same, leave them alone. You don't have to do anything. We may have to change things after the fact, but if our first element's numbers on both the reactant and the product side are the same, don't touch them. Go to the problem area. We see in our reactant side, we have 2 atoms of oxygen over here on the left, but we only have 1 of them over here on the right. It's a very simple fix. We are going to take and add a coefficient in this blank right here. That coefficient is going to be the number 2. Now the problem is, when I add that coefficient in that blank, I have to distribute it to both elements in that grouping. So I am going to distribute it to the oxygens, but I also have to distribute it to the magnesiums. You know, guys, I hear the cops outside. I think they're coming for me. Yeah, we're good. Okay, anyway, guys, here's what this is going to look like. Over here on the product side of our wrap table, we're going to start crossing out and changing some numbers here. Okay. Now, when I distribute this 2 to my magnesium, it's going to change the amount that I have right there. That now becomes a 2. It's a basic multiplication problem. 2 times 1 is 2. Now, unfortunately for us, we made that change here, and it's going to kind of make things all wonky-donkey for us over on the reactant side, but we can fix that in just a minute. Let's go down here, though, because remember, this was our problem area, the oxygens. What we were able to do by adding that big number is we could change, and now our amounts of oxygens are in line. They're balanced, okay? Unfortunately, we unbalanced our magnesiums, but it's a very simple fix. In order then to make this magnesium match up to that one, we're going to go back over here. Nobody says we can't go back and fix things. We're going to go back over here to this reactant side, and we got to make this magnesium right here have the same number as this magnesium here. So we're going to use this big coefficient again. I'm going to put a number 2 in this first blank, and I am going to distribute it to every element in that group. Guys, there's only one element. It's magnesium. What we are trying to accomplish here is that when we look at our wrap table, all of the numbers for the elements are balanced. And once we are able to do that, guys, that's how we balance a chemical equation. Now, for some of you, that might be super easy. Some of you guys are going, oh, I get this. Some of you guys are going, I have no clue what's going on. Don't panic, okay? We're going to come back tomorrow. We're going to spend some more time practicing some of these problems. You guys are going to practice a little bit at home as well, because then, guys, on Friday, I'm going to have a small little assignment for you guys to do when it comes to balancing these things, okay? I hope this was helpful. Again, if you have any questions, make sure you hit me up. Send me an email. Mr. Collison, I don't get this. Can we Zoom? Can we kind of work this out? Absolutely, guys. I am available for you whenever you need it. Please make sure you use me as a resource if it is needed, okay? All right, guys, I'm going to go ahead and stop my share so I can stop my video. Again, we'll come back on Thursday, and we'll continue working on some of these balancing equations. See you then.